Hey guys, it's Miss Lassiter. I am going to try to show you how I understand the concepts in this chapter and the definitions of the different vocabulary words by solving the equation on the next page. The equation looks fairly complicated, so I'm first going to cover it up and then only look at one half of it. When I look at this as 3x plus 14 plus 2x minus 1, this would be an algebraic expression because there are letters and there are numbers. There would also be 4 terms in this expression because one term is the 3x, one is the 14, another one is the 2x, and another one is the 1. I can't solve this. All I can do with an algebraic expression is simplify it. So I'm going to go ahead and try to simplify this expression. I'm going to think of it as envelopes. So I have 3 envelopes with each having X dollars in it. I have $14. I have 2 envelopes each having X dollars. And someone took $1 away. So I'm going to first look at my envelopes. And I'm going to, these are considered like terms because they're both envelopes, each having X dollars in them. There are 3 envelopes and 2 envelopes. So I'm going to simplify this expression by combining like terms. So my 3 envelopes and 2 envelopes, it gives me 5 envelopes. And then I am going to look at my money. I have $14 and someone took away $1. So it's a net value of having $13. So now on this side of the equation, it's going to be an equation, is the expression 5x plus 13, which is an algebraic expression that cannot be simplified. So if it was just talking about this expression, I could evaluate, which means find the value of this expression for different values of x. If I vary the values of x, that helps us understand why they call these letters variables. So I'm going to uncover the rest of my screen because algebra is often made up of equations. So once you enter an equal sign, then it becomes an equation, and I try to solve the equation. So I'm going to look at the right side in the same way that I looked at the left side, and I'm going to think of, oh, there are 9 envelopes, and then an extra $5. We took away 2 of the envelopes, and then we took away 12. These 4 terms by themselves would form an algebraic expression, and so I'm going to try to simplify this algebraic expression, and I'm going to look at the envelopes. There are 9 envelopes, and we take away 2 of the envelopes, so we end up with 7 envelopes. And then there are $5 added on, but then someone wants to take away 12. So they could take away 5, but then they would still need to take away 7 more. So now the right side is simplified to 7x minus 7, which is an algebraic expression that cannot be solved. And so we're going to look at this. Now, when would the left side and the right side be the same? So we're going to look for, is there a value of x or a value of money that you can have in each envelope that would make it so the left side and the right side have the same amount? So you can always try trial and error, but I would like you to try to focus on the fact that by the properties of equality, I can add the same thing to both sides, subtract the same thing to both sides, multiply both sides by the same thing, or divide both sides by the same thing. So I'm going to look at envelopes. I have 5 envelopes on my left, and I have 7 envelopes on my right. Can I remove envelopes from both sides? Yes, I can remove 5 envelopes. So I'm going to remove them by taking away 5 envelopes from both sides. So on the left side, I have 13 remaining because my envelopes are all gone. And on the right side, I have 2 envelopes remaining, but someone took $7 from them. So I need to work on that. So I am going to try to get these envelopes just by themselves. So the opposite of taking away 7 is I'm going to add the 7 envelopes back in. I have $7 back into the envelopes. And I have to add $7 on this side too. So I end up that I have $20 on my left, and I have 2 envelopes on my right. Most of us know the basic math fact that 2 times 10 is 20, so we know x equals 10. But you can also think that this 2 is connected to the x by multiplication, so I can undo it by dividing. So I get x equals 10. One of the most important steps of the process is to take this answer and substitute it back in to the original equation. So I'm going to do 3 times 10 plus 14 plus 2 times 10 minus 1 equals 9, equals what, question mark, would equal 9 times 10 plus 5 minus 2 times 10 minus 12. So 3 times 10 is 30. 30 plus 14 is 44, plus 20 is 64, minus 1 is, so I get 63. Then on the right side, I have 9 times 10 is 90. 90 plus 5 is 95. Minus 20 is 75. Minus 12, 63. And then I can do a happy dance and say, yes, I know the answer x equals 10 is correct.